Today we're on page 9 of the second half of our Chapter 5 notes packet. Section 5.9, Solutions of Systems of Equations and Inequalities. You'll need your graphing calculator with you while you're watching this video. Systems of equations is a set of two or more equations. A system that consists of a quadratic equation whose graph is a parabola and a linear equation whose graph is a straight line is called a quadratic linear system in two variables. In the set of real numbers, such a system may have two, one, or no solutions. Each solution can be written as the coordinates of the points of intersection of the graph of the parabola and the graph of the line. So here we just have an example. Three diagrams. We have a parabola and the intersection of a line. They intersect at 2 points, so you would have two solutions. In the next diagram, a parabola and our line intersect at just 1 point, so there would be one solution. And where the parabola and line do not intersect at all, there would be no solutions. Solving systems of equations graphically, use a graphing calculator, calculate the points of intersection, and remember you must always isolate y before keying it into the calculator. Steps for solving algebraically. Isolate one variable in one equation and then substitute it into the other equation and solve. So we're going to go through 4 examples where we're going to solve each system algebraically and graphically. So number 1 here, we'll solve algebraically first. Our first equation, this is our linear equation. Its graph would be a line. Our second is our quadratic. Its graph would be a parabola. And hopefully you recall that since the leading coefficient is negative, this would be a parabola that is facing concave down. This variable is already by itself, so what I'm going to do is we'll take the linear part, the x plus 2, and just replace it in for y into our quadratic. So we have x plus 2 is equal to negative x squared minus 3x plus 7. Now we want to solve this algebraically, so it's quadratic. Put it in standard form. Remember, I always want the lead coefficient to be positive, so I'm actually going to take the 3 terms on the right-hand side and bring them over to the left-hand side by adding x squared, adding 3x, and subtracting 7. And no, you do not have to show this step. We have x squared plus 4x minus 5 equals 0. Now, this looks like a quadratic we're more familiar with. What are the factors of negative 5 that add to 4? Positive 5, negative 1. So our factors are x plus 5 times x minus 1 equals 0. Set each equal to 0. I'll skip that step, go right to the 2 values for x. Now these are x values. We have to find the corresponding y value that goes with each x, right? Because our original equations were in 2 variables. So when x is negative 5, what's the value of y? I'll go back up to the linear equation, and negative 5 plus 2 would equal y. Negative 5 plus 2 is negative 3. So when x is negative 5, the y value is negative 3. And we would write it as an ordered pair. And when x is 1, y equals 1 plus 2, which is 3. So when x is 1, y is 3. So here we have 2 solutions. Now let's look at the graph. And again, we're just sketching the graph. So go to your graphing calculator, go to y equals, and let's key in. Our linear equation is x plus 2, and our quadratic, negative x squared minus 3x plus 7. Double check, didn't miskey anything. Well, I certainly did. Good thing I double checked. This is an x. Okay, now press graph. There's our line, and now here's our parabola. Let's sketch these two on the XY axis that are provided for us. Okay, we have two graphs. Don't forget, make sure to label them. X plus 2 equals y is our line. And our parabola y equals negative x squared minus 3x plus 7. And note the points of intersection. Now, if we hadn't found them algebraically already, then we could look at the table on our calculator. Actually, I'll do that. If I look at the table, here you go. There we go, 1, 3. See how both y values are the same? So that's one solution. And then negative 5, negative 3. Next, page 10. Number 2. Our first equation here is our quadratic. Our second is our linear. This one is already isolated, right? The y is isolated. So what we can do is we can simply replace y in our linear with the three terms. So we would have x plus 3x squared minus 2x plus 4 equals 6. I simply took the linear, replacing the y with the three terms that y is equal to. Okay, there's a plus out in front, so that means I can just drop the parentheses and combine like terms. 3x squared, positive 1x and negative 2x is negative 1x, plus 4 equals 6. Let's get it in standard form. Subtract 6 from both sides. 3x squared minus x minus 2 would equal 0. Now a factor. Lead coefficient's not 1, it's 3, so we multiply 3 times negative 2 is negative 6. The factors of negative 6 that add to negative 1 are negative 3 and 2. This is kind of off to the side here. 3 is going to start each of our binomials in the numerator, and 3 goes down into the denominator. This is a factoring in, factor out. 3x minus 3, 3x plus 2, and 3 divides evenly into 3x minus 3. So we have x minus 1 times 3x plus 2, are our factors, equals 0. We set each equal to 0, and x equals 1, and x equals subtracting 2 and dividing by 3, negative 2/3. Now for each x value, we have to find the corresponding y. Again, I'll go back up to the linear equation. So 1 plus y equals 6. Subtract 1, y equals 5. So 1 comma 5 is one solution. And negative 2/3 plus y equals 6. If I add 2/3 to both sides, oh, how we love fractions. Y equals, we could say 6 2/3, that would be fine. As an improper fraction, that would be 20/3. So we have as our second solution negative 2/3 and 6 2/3. Go to your graphing calculator. Y equals, let's clear this out, put in our two equations. X squared minus 2x plus 4, and for the linear one, right, we have to have y by itself. So if I subtract x from both sides, we have y equals, you can write it as 6 minus x, or you can write it negative x plus 6, whatever your preference is. Look at the graph. There we go. There's our parabola and our line. Now let's sketch the graph on our x and y axis. Make sure you label each. We have x plus y equals 6, and our parabola 3x squared minus 2x plus 4 is equal to y. Note our points of intersection. 1, 5 and negative 2/3 and 6 2/3. If we hadn't figured out the solution algebraically already, how would we get the solution graphically? This point of intersection, recall, second, trace, calculate, in this case number 5, the intersection. First curve we hit enter, second curve we hit enter, and then for the guess, I'm fairly close to the point on the left hand side here. If I want, I can get a little closer, but here's the intersection. Negative 0.6 repeating, that's equivalent to negative 2/3, and 6.6 repeating is 6 2/3. Next, question number 3. Our quadratic, x squared minus x equals y plus 3. Let's get one of these by itself, because once we key it into the calculator, we'll need y by itself anyway. So subtract 3 from both sides, and we'll have y equals x squared minus x minus 3. And for our linear, that we already have y by itself. Now I'll go to my linear and replace the y with x squared minus x minus 3. So x squared minus x minus 3 equals negative x minus 3. Write it in standard form, add x and add 3 to both sides, and we have x squared equals 0. Square root both sides, x equals 0. Looks like we have only one value for x. I'll go back to linear only because it's simpler. I don't have to do any squaring. When x is 0, y equals negative 0 minus 3 is simply going to be negative 3. So 0, negative 3 is our only solution. Let's look at the graph. All right, y equals x squared minus x minus 3. And negative x minus 3 is our second equation. There's our parabola, and there's our line. And see how they intersect at only one point. Try to draw this fairly accurately. It's close. 0, negative 3. So we note the point of intersection. Let's not forget, make sure we label our graphs. Minus 3. And the fourth one, page 11. I'll take the quadratic, and again, since when we go to graph it, we'll need to have y by itself. I really want to just kind of add y to the other side and then bring the other two terms over to the left-hand side. All right, so if I add y to this side and then bring these two over, I'll have x squared minus 3x plus 2 equals y. And for our linear, subtract 4x, so I have y equals negative 4x minus 1. Now, I'll take my linear, y equals negative 4x minus 1. I'll take the negative 4x minus 1 and substitute it in place of y above. So we'll have x squared minus 3x plus 2 equals negative 4x minus 1. Let's put it in standard form, add 4x and add 1 to both sides. Again, you don't have to show this work. X squared plus x plus 3 equals 0. We factor, there are no factors of 3 that add to 1. Complete the square. Well, let's go to the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So a is 1, b is 1, and c is 3. So x equals negative 1 plus or minus the square root of 1 minus 12 is negative 11 all over 2. Okay, that's not real, that's imaginary. Just for review, let's simplify this anyway. Negative 1 plus or minus I square root of 11 all over 2. Well, there's no real solution. There's no real x value, so there's no real solution. Well, let's look at our graph. Y equals x squared minus 3x plus 2 and negative 4x minus 1. There we go. Our parabola and our line do not intersect. So no points of intersection, no solution. And let's not forget to label with their equations. Y equals negative 4x minus 1 and y equals x squared minus 3x plus 2. And the last page, page 11, we get into quadratic inequalities. Recall, if we have y is less than our function, for less than, our graph is going to be dashed. It's not solid. It would be a dashed graph or dotted graph. And for less than, you shade below. For greater than, your graph would be dashed or dotted. And for greater than, your shading is above your graph. For y less than or equal to, the equal to part means that your graph is solid. Okay. And still less than, you would shade below. Greater than or equal to, your graph would be solid, a solid line or solid curve. and shading would be above your curve. So we want to match the inequality with its graph. So let's be smart about this. We don't have to actually key it into the calculator or anything. All right. For number 1, you have y is greater than or equal to negative x squared plus 4x minus 3. Well, the greater than or equal to, that means that our graph would be solid for the equal to part. And for greater than, we would shade above. And the parabola itself, since the lead coefficient is negative, right, our parabola would be concave down. So it would look like this. So which one of our 6 choices, all right, do we have a concave down, solid graph parabola with shading that is above the parabola? Right? Would be this one, C. So number 1 matches with the graph of C. Number 2, y is less than or equal to negative x squared minus 4x minus 3. The less than or equal to part means it's going to be solid. Less than, you shade below. And the parabola itself, since it's negative, is shaped concave down. Shading below, solid, concave down. That matches A. Shading below, solid, concave down. Number 3, less than or equal to, solid, shade below. The parabola, since the lead coefficient's positive, would be concave up. So we want solid, concave up with shading below. Here we are. Solid, concave up, shading below. So F is our graph for number 3. Number 4, y is less than x squared minus 4x plus 3. The less than means we're going to have a dashed line or curve, and the shading would be below our curve. And the parabola, we have a positive coefficient, so it would be concave up. So dash concave up with shading below is what we're looking for. Dash concave up with shading below. E. Number 5, greater than, dashed, greater than, shading above, and lead coefficient is negative, so our parabola would be concave down. So dash concave down with shading above. Here we are, right here at B. And number 6, well, I know that only leaves us with D, but let's just work it through. Greater than, dashed, shade above, and the parabola itself, lead coefficient's positive, so it would be concave up. So concave up, dashed, shading above. Yep, that is D. And now finishing up, state 1 point in the solution set for each of the above graphs. Again, there's many more. All right, this is just one. For example, here, if I take the negative 2, 0, you can't see that. All right, negative 2, 0 for A. For B, I'll pick 0, 0. So you're looking for a point in the shaded region. That would be a point in the solution set. The shaded region is a solution set. For C, I'll take 0, 0 again. That's in the shaded region. I really like 0, 0. I can use that for E as well. All right, but oh, let me differ. Let me say -2, 0. And F. Cannot use 0, 0 here. I'll go with -4, 0. All right, this concludes our Chapter 5 notes.